Hey guys, I started a new lecture video series, and as you know, we are already doing the Jam and Net lecture series, which is actually a long one, right? So this lecture series has been started in the mindset that I plan to do some short videos, like say in the range of 5 to 10 minutes, within 5 to 10 minutes, right? So for such a thing, I started this with lecture series, and this lecture series may help for preparing Jam, Gate, QGAT, NET, APSC geologist, and even other state board geologist examinations. So this is what the prime idea in starting this lecture series, and the first lecture will be on geosyncline. Welcome to my channel Success Guru and myself Panchanadam, and let's get into the same heading. What is geosyncline? The fundamental concept of geosyncline theory were introduced in James Hall's Presidential Address for Geological Society of America at the meeting of American Association for Advancement of Science at Mantle in 1957. Once he was exploring the Appalachian Mountain, he found one thing, that is, the principal concept of the theory is that the direction of the given mountain chain corresponds to the original line of the greatest sediment accumulation. So what you want to explain is that the mountain chain range is in a direction which is somewhat parallel, that is, the trend is somewhat parallel to the coastal line. So this is the base for this concept, and which has been actually what do you call it, which has been reworked by James Dana, who helped to clarify the theory in his final edition in 1895 of the Manual of Geology. In this piece, he recognized Hall's beginning and concisely formulate the theory. And the theory is that the geosyncline is a term occasionally used for the subsiding linear trough that was caused by the accumulation of sediments deposited in a basin and subsequently compressed, deformed, and uplifted into a mountain range, accompanied with volcanism and plutonism. So the concept is that there was a basin, the sediment was deposited there for a longer time, and the sediment was subsiding along with the deposition, and once again, what happened? The overall basin has been uplifted. That is, the rocks has been exposed to the surface. Along with that, there will be volcanism as well as plutonic type of intrusions. So this is what the basic concept of geosyncline, and this has been classified further by many guys. The one is that K in 1944, 1947. According to him, geosyncline can be classified into two. That is orthogeosyncline and parageosyncline. Whereas the orthogeosyncline is that these are the geosyncline which are linear, deeply subsiding, shallow to deep water environment located between the craton. It is further classified into eugeosyncline and myogeosyncline. So according to him, that is the new concept what we call it as a mobile belt is considered to be a geosyncline, that is in between two cratons, right? So here classified into two, that is EU geosyncline, myogeosyncline, where EU geosyncline was the active subsiding with associated volcanism. So in this case, what happens? The subsiding is actively taking place. That is a shallow dip. That is when the sediment is deposited, it will be subsided along with the rate of sedimentation. Okay, whereas in myogeosyncline, these are less active and there is no any such volcanism. So according to his classification, orthogeosyncline or the border of a craton, right? And it is classified into two. One is an active and other is somewhat nearly passive. Okay. And the second category is that parageosyncline, and these are the intracratons with ovate shape, less active, located within a craton or adjacent to it. It is further classified into exogeosyncline, autogeosyncline, zeugogeosyncline, and tephrogeosyncline. So this is inside a craton you will find some geosynclines, and it has been classified into four. Let us see one after the other. The first one is the exogeosyncline. It is the transverse basin, that is a tongue-like extension from orthogeosyncline. So it is extension of a margin of craton towards the interior, right? And the best example is that Sivalex in India, right? And the second one is the autogeosyncline, that are the isolated basins with ovate in shape. The rate of the subsidence decreases from the center. So it is somewhat near a saucer shape, right? So such a type of geosyncline which is having a more thickness at the center is called as a autogeosyncline. And the best example is that Papagni series. The third one is the zeugogeosyncline, that is York basin ovate or linear in shape, adjacent to a complementary uplift in the craton with the subbravecate. So this geosyncline has been formed, that is near a complementary uplift, that is there is some portion has been uplifted, and due to that upliftment there will be a depression in the nearby region, and that forms a geosyncline that is called as geosyncline. And one of the best examples is the Srisaila deposits. Okay, the last one is the Tephra geosyncline. These are the riftogenic basins of continental origin, and the best example is the Godavari graben, which is active now, right? So these are the classification according to K. That is, one is the orthogeosyncline, that is in the border of the craton, and the second one is the parageosyncline, which is inside a craton, right? Okay. But this classification have no relationship with the tectonic setup, right? So there is a guy who classified this geosyncline in related to the tectonic setup. So that is by Mitchell, Readings, Dickinson, Hazu, geosynclines are classified into six. So these all guys group together and classify the geosynclines into six types, which has been correlated with the tectonic setup. So let us see that. The first one is the Red Sea type. That is, the sedimentation is in a divergent zone. They are formed during the initial stage of a continental breakup, characterized by alkaline volcanism. That is like Allakogen. Okay. So the first one is the Red Sea type, which is the initial stage of a continental breakup. That is what the first type, that is Red Sea type. The second one is the Andean type, that is the continent, that is formed in the continental margin. The ocean continent collusion, that is in the convergent boundary, right? You can see here the alkaline volcanism and the epigenetic affiliation in the western South American margin. So this has been found in this region and it has been named as the Andean type. The first one is the Red Sea type, which is the right area for that, and second one is the Andean type. The third one is the Japan Sea type, which is the marginal sea basin occurring continental world of the island arc. So you know the island arc system, right? So the back arc basin is called as a Japan Sea type. The fourth one is the Atlantic type, which is the eastern part of the North American, formed at a continental margin in the interior of the plate from a geosyncline couple. Evaporates and metalliferous muds are chiefly deposited here. That is the Atlantic type of geosyncline. The next one is the Mediterranean type, which is the originated in the plate margin, showing a dominant lateral plate motion. So you were discussed about the transform faults, right? So these are some of the examples for that. The last one is the island archetype, which has been classified into two, that is the Allochthonous and Autochthonous, whereas Allochthonous are formed outside the trench environment and transported into the deposit, right? For example, podiform chromite is like that, right? And the second one is the Autochthonous, that is formed within the geosyncline complex itself. Okay, so let us compare this classification with the tectonic setup. The first one is the Red Sea type. That, as you know, that is the initial stage of a continental breakup. So in a divergent boundary, that is continent divergent, right? So this type is called as Red Sea type. The second one is the Andean type, where in this case you can see that is a convergent boundary between the continent and ocean. So when the continental plate and ocean plate converges, the oceanic plate, which is having a higher density, that is subsiding beneath the continental plate, right? And this forms a geosyncline. The type of geosyncline is called as Andean type, which is somewhere. The third one is the Japan Sea type, which is a convergent boundary of continent ocean, right? But here what happens, the volcanic arc has been formed in the continental type, and there is a back arc basin that is in the continental portion itself. Okay, so this is called the Japan type. The fourth one is the Atlantic type, which is here you can see this is the Atlantic Ocean, right? So here is a mid-oceanic ridge and there is a ocean divergence taking place, right? So this is called the Atlantic type of geosyncline. Then there is a Mediterranean type, which is actually in the Mediterranean Sea. You can see there is a transform fault, which is, you can also see the same thing in San Andreas fault, right? So these are some of the example of Mediterranean type, where there is no convergence or divergence, only the plate transpasses each other. And the last one is the island arc type, where you can see ocean collision. When the ocean collides, the high density plate submerges down, right? Subduct down, right? And that leads to the formation of island arc. And such a type of environment is called as island arc type, which is the sixth type in this classification. So these are the geosyncline in general, and I made short video, right? So I want to complete it in a shorter period. So with this, I'm completing this video. If you have any doubt, you just text me in the comment section. I will try to explain in the next video. I have grouped my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook, and Instagram, and these are the links. You can support us by like, share, and subscribe. Thanks for watching. Have a great day.